Hello students, myself Dr. Ahmed. I welcome all of you to the next session of Bridge Course for Engineering Mathematics. Students, in the last session we have started the topic called derivative or differentiation. Students, in that we have seen what is the meaning of derivative at a point. Suppose I am having a function, f of x, then at the point x equals to c, the derivative of this function is given by f dash of c equals to limit h goes to 0 f of c plus h minus f of c by h. So this was the definition for derivative of a function f of x at the point x equals to c. This we have seen in the previous class, and also we have seen the geometrical interpretation of the derivative. What is the geometrical interpretation of the derivative? It is nothing but, suppose I am having a graph of the function f of x, then at this point suppose if I want to find the derivative, then the value of the derivative is nothing but the slope of the tangent drawn at this point. Whatever the slope of this tangent at this point is given by c comma f of c. At this point, whatever the slope we are having for the tangent, that will give us the derivative, right? Derivative is nothing but the slope of the tangent drawn at the point for the function f of x. Geometrically, derivative is slope, right? Next, after that we have seen differentiation by first principle. That is, we have seen derivative of the function at any point, that is f dash of x is given by limit h goes to 0 f of x plus h minus f of x by h. This is called as differentiation by first principle. So by using this formula, in the last class we have evaluated various derivatives and we have found a few formulae, standard formulae, by using this formula, right? This is called as differentiation by first principle. Now students, we are going to establish few rules for differentiation. In today's class we are going to study few rules for differentiation. So out of that, so I'll put the title Fundamental Rules for Differentiation. So the title is Fundamental Rules for Differentiation. Now in this we are having the first one theorem, or you can consider this as theorem 1, means it's a rule, right? What it says, suppose I am having a function, let f of x equals to k, then df by dx is nothing but 0. That is the derivative of constant. Df by dx, you can even write it as d by dx of constant is 0, right? So how to prove this? What is there? Function is given f of x equals to constant, then we have to show that the derivative of this is 0, right? So what is given? F of x is given, f of x equals to k. Now this implies, what is f of x plus h? What is f of x plus h? Wherever x is there, we have to put x plus h. Here no x is there, so this will be k only, right? Next, now from the first principle, from the formula of first principle, how to find the derivative? F dash of x, which is nothing but df by dx, is given by limit h goes to 0 f of x plus h minus f of x by h, right? This is from first principle. Now next, this is equal to limit h goes to 0. What is f of x plus h? F of x plus h is given by k minus f of x. F of x is given by again k. This is divided by h. Now the value of this will be 0, right? So the derivative of constant is always 0. Geometrically, what is the meaning of this? Derivative of constant is always 0 means, geometrically the meaning is the slope of the tangent drawn at the point. We will see geometrically what is the meaning of this. Suppose I am having x-axis and y-axis, then constant, graph of a constant function will be given by, suppose this is some k, then the graph of this constant function is given like this. This is f of x equals to k. This is the graph of this line is the graph of f of x equals to k. Then this derivative should be 0. This derivative f dash of x should be 0, means derivative is actually the slope. Slope is 0. Slope is 0 at every point. You can see, suppose if the curve is like this, then I can draw a slope like this, a tangent like this, which is having some slope. Slope is 0 means this tangent should be straight. Tangent should be straight. If you try to draw the tangent for this line, the tangent is itself. The tangent is the line itself, right? The tangent for this line is the line itself, and the slope of this line is 0. So for a constant function, the slope will be 0. That is the geometrical meaning of derivative of a constant function is equal to 0. Geometrically, it means that the slope of tangent drawn in the graph of the function is 0, right? Hope you have understood this. The next rule we will see. The first rule says that the derivative of the constant is 0. This is the first rule. Now second rule says that now let us consider the rule 2, that is theorem 2. It says that if f of x is differentiable, if f of x is differentiable, then d by dx of some constant a into f of x is nothing but a into derivative of f of x. This is the second rule for differentiation. Means along with the function, if some constant is there, and if we are finding the derivative of the total, then constant is independent of x, so constant can be taken out. Then whatever the terms that are depending on x, that should be differentiated, right? What is the meaning of this? If f of x is a differentiable function, then d by dx of a into f of x is nothing but a into d by dx of f of x. What is the meaning of this? If a function is multiplied with a constant, right? If a function f of x is multiplied with a constant, and if we are supposed to find the derivative of the total multiplication, the product, then because a is a constant which is not at all depending on the variable x, so that should be taken out. A is taken out, remaining we have to differentiate only the terms which are involving x. This is the rule. Now we will see few problems related to this. So till now we have seen two rules. First rule is derivative of constant is 0. Second rule is derivative of a constant into function is nothing but the constant should be taken out and the function should be differentiated. On this rule, on these two rules, we are going to see few problems. So find the derivative of following. What is the question? Few functions will be given. We have to find the derivatives of that. Out of that, the first function is 9 into 3 power x. The function is 9 into 3 power x. We have to find the derivative of this, right? d by dx of 9 into 3 power x, which is equal to, so just now we have seen that if a constant is there and f of x is here, you can consider this as in this form, a into f of x, 9 into 3 power x. 9 should be taken out because of this rule, 9 should be taken out. Then d by dx of 3 power x, right? 9 as it is. Now we have to differentiate 3 power x. Yesterday we have seen a formula, that is d by dx of a power x is nothing but a power x log a, right? From this formula, d by dx of a power x is nothing but a power x into log a. Now a in place of a we are having 3, so it is nothing but 3 power x log 3, right? So the derivative is, derivative of 9 into 3 power x is nothing but 9 into 3 power x log 3. So here which rule we have used? We have used this rule, a into f of x rule we have used, right? Next we will see one more problem. Second problem, in which e power 3 log x is there. We have to find the derivative of exponential of 3 into log x, right? So solution, d by dx of exponential of 3 into log x. This is equal to, now further this can be written as d by dx of e power, this 3 can be taken on x, log of x power 3, right? This 3 I am taking here, right? We can do this. Then what will happen? D by dx of exponential and logarithm will get cancelled because general natural logarithm base will be e. So exponential power log base e will get cancelled. So what will remain? Only x power 3 will remain. And yesterday we have seen a formula, d by dx of x power n is nothing but n into x power n minus 1. So in place of n, now I am having 3. So what will get? 3 into x power 3 minus 1, which is nothing but 3 into x power 3 minus 1 is 2. Therefore, the derivative of e power 3 log x is given by 3 into x square. So which rule I am using here? Which formula I am using here? D by dx of x power n formula, which is nothing but n into x power n minus 1. I will explain once again what I am doing here. E power 3 log x is there. That can be written as d by dx of e exponential of this 3 I am writing on the power of x, that is log x cube, right? Then what will happen? This exponential and logarithm will get cancelled. What will remain? D by dx of x cube will remain, and the derivative of x cube can be found by using this formula, that is 3 into x power 3 minus 1, which is 3 into x square. Fine. Hope you have understood these two problems. Here we have used the rules. Just now we have studied two rules. Derivative of constant is 0. Second rule is derivative of a into f of x is nothing but a into derivative of the function. So by using these two rules we have seen some few problems. Now we will go for the next two rules. So up to that you have a look at this. Okay students, next we are having one more rule, that is theorem 3, which says that let f of x and g of x are differentiable functions. What I am considering? I am considering f of x and g of x are differentiable functions. Then d by dx of, I am considering f of x plus or minus g of x. What I am considering? D by dx of f of x plus or minus g of x. This is nothing but, we can separate the derivative over addition or subtraction, means d by dx of f of x plus or minus d by dx of g of x, right? What I am able to do, this rule says that the derivative can be distributed over the addition or subtraction, means if two functions are there in addition or subtraction, and if we want to find the derivative of that sum or subtraction, then this derivative can be separated over f of x and g of x, right? This is what the rule says, right? This can also be written as d by dx of u plus or minus v, where u and v are functions of x only. Instead of f and g, I am taking u and v. This is nothing but du by dx plus or minus dv by dx, right? Just I am changing the notations from f and g to u and v. In general, this rule can be written as, suppose I am having n functions. Here how many functions I am having? Only 2, f and g. Instead of this, suppose I am having some n functions, then d by dx of f1 of x plus f2 of x plus or minus also we can consider, plus or minus and so on up to fn of x, right? And what I am considering? I am considering the summation of n functions, that is 1, 2 up to n. Then here instead of 2 I am considering n functions. Then the same rule is applied. We can differentiate f1 with respect to x, f2 with respect to x, and so on. That is df1 by dx plus or minus df2 by dx plus or minus, and so on, plus or minus dfn by dx, right. So this is the general form of this rule, right. Now we will see few problems related to this rule. So problems, we will see the problems now. Differentiate the following functions. Differentiate the following functions. Differentiate the following functions with respect to x. With respect to which variable we have to find? We have to find the differentiation with respect to x, means d by dx, right. So out of that, first problem is x square plus sin x plus 1 by x square. This is the first problem. We have to find the derivative of x square plus sin x plus 1 by x square. So solution, d by dx of x square plus sin x plus 1 by x square. This is equal to, see just now we have seen that f1 plus f2 plus one more function f3 is there, then df1 by dx plus or minus df2 by dx plus or minus df3 by dx. The same thing, f1 is x square, f2 is x, and f3 is 1 by x square. So this derivative can be distributed over the addition, that is d by dx of x square plus d by dx of sin x plus d by dx of this 1 by x square can be written as, if you take this x square in the numerator, this power will become negative, that is x power minus 2, right. Now d by dx of x power n formula we have to use. D by dx of x power n is nothing but n into x power n minus 1. The same thing we have to use here, 2 into x power 2 minus 1 plus d by dx of sin x. Yesterday we have seen this formula also, d by dx of sin x is nothing but cos x, right, plus again d by dx of x power minus 2. The same rule we have to use. What will happen? Minus 2 into x power minus 2 minus 1. Further we can simplify this. 2 into x power 2 minus 1 is nothing but x plus cos x minus 2 into 1 by x power minus 2 minus 1 is nothing but x power minus 3. If you take that x power minus 3 in the denominator, that will become x power 3. So the derivative of x square plus sin x plus 1 by x square is nothing but 2x plus cos x minus 2 by, this can be written as 2 by x cube, right. So we have used this rule now. We have used, because the given function was in addition form, we have used this rule, right. Similarly, we will consider one more problem, the second problem, right. What is the question? Ax square plus bx plus c by square root of x, right. The next problem is ax square plus bx plus c by square root of x. Solution. What we have to do now? We have to find the derivative of this. D by dx of, with respect to x, we have to find the differentiation. Ax square plus bx plus c by root x. This is equal to, we can write this as d by dx of ax square by root x. I am separating the denominator for each term. Ax power 2. Now root x is nothing but x power 1 by 2. Root x is nothing but x power 1 by 2. If you take that above, x power minus 1 by 2. Already x power 2 is there, and from this we are getting x power minus 1 by 2. So x power 2 minus 1 by 2, right. Similarly, plus b into x power 1 is there, and from the denominator we are getting minus 1 by 2. So 1 minus 1 by 2, and here plus c into x power only 1 by 2. That will become minus 1 by 2. Right? Hope you have understood this. What I have done here, a x square is there and here root x is there. Root x is nothing but x power 1 by 2. When you take that x power 1 by 2 in the numerator, that will become minus 1 by 2. So a x square, a x power 2 minus 1 by 2. Similarly here a b x power 1 minus 1 by 2. And here c into x is not there. So directly we will get this term only, that is x power minus 1 by 2. Right? We can separate this because this function and this function are in additive, in summation. We can distribute this derivative on each term, and a is a constant that can be taken out. So what will remain? D by dx of x power, what will happen? 2 to the 4 minus 1, 3 by 2, right? Plus b into d by dx of x power 1 minus 1 by 2 is 1 by 2, plus c into d by dx of x power minus 1 by 2, right? Now we have to differentiate all these terms by using x power n formula, d by dx of x power n formula, which is a into x power n. Derivative of x power n is nothing but n into x power n minus 1, that is 3 by 2 into x power 3 by 2 minus 1, plus b into 1 by 2 x power 1 by 2 minus 1, plus c into what will happen? Minus 1 by 2 into x power minus 1 by 2 minus 1, right? Let us simplify this. What will happen? 3a by 2 x power 3 by 2 minus 1. What will happen? 2. So we will get 1 by 2, plus here b by 2 x power 1 by 2 minus 1 by 2 is nothing but minus 1 by 2. Here minus c by 2 x power minus what will get? 3 by 2, right? Further we can simplify 3a by 2 x power 1 by 2 plus b by 2 1 by x power minus 1 by 2 can be written as root x, minus c by 2 x power minus 3 by 2 can be written as 1 by x power 3 by 2. So this is the required answer, right? I'll explain once again because this problem is a little bit difficult compared to the previous problems. So I'll explain once again. What we are doing, a x power 2 is there, right? A into x power 2, and here x power 1 by 2. When you take this x power 1 by 2 in the numerator, we'll get x power minus 1 by 2. So 2 minus 1 by 2, here 1 minus 1 by 2, and here c into x power minus 1 by 2. When you simplify this, what will happen? 2 to the 4 minus 1, that is 3 by 2. Here 1 minus half is half, minus 2 minus 1 by 2 as it is, right? Then we have to differentiate this by using the formula derivative of x power n, that is n into x power n minus 1. We have to use that formula, n into x power n minus 1. The same thing here, n into, that is 1 by 2 into x power 1 by 2 minus 1. Same thing, minus 1 by 2 into x power minus 1 by 2 minus 1. Right? Now what will happen? 3a by 2 x power 3 by 2 minus 1 is nothing but 1 by 2. Here b by 2 x power 1 by 2 minus 1 is nothing but minus 1 by 2. Here minus c by 2 x power minus 1 by 2 minus 1 is nothing but minus 3 by 2. When we simplify this, we will get the required answer. Hope you have understood this. Have a look at this, students. Okay, students, next we are having few more problems. The third problem is, if y equals to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on, then we have to show that dy by dx equals to y, right? So first we will find dy by dx, then we will see whether we are getting again this y or not. Expression for y is given to be 1 plus x by 1 factorial plus x square by 2 factorial and so on. So we will consider solution. What is given? Y equals to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus I'll write one more term x power 4 by 4 factorial plus so on. Then we will find dy by dx. Let us see what we will get. Means we have to differentiate each term of this because the derivative is distributive over addition. So what we will get, d by dx of 1 plus d by dx of x by 1 factorial plus d by dx of x square by 2 factorial plus d by dx of x cube by 3 factorial plus d by dx of x power 4 by 4 factorial plus so on, right. Then what will happen? Derivative of 1, that 1 is a constant, derivative of constant is 0 plus this 1 by 1 factorial as it is, 1 by 1 factorial as it is, derivative of x is 1 plus 1 by 2 factorial as it is, 1 by 2 factorial as it is because it is a constant, derivative of x square, that is 2 into x power 2 minus 1 is nothing but 2x plus d by dx of plus 1 by 3 factorial as it is, 1 by 3 factorial as it is, derivative of x power 3 is 3 into x power 3 minus 1 which is 2 plus 1 by 4 factorial, derivative of x power 4 is nothing but 4 into x power 4 minus 1 which is 3 plus so on, right. This term is 0 and here what will happen, 1, it is 1 only, 1 by 1 factorial is 1 only plus here what will happen, 2 factorial is nothing but 2 into 1 factorial, 2 will get cancelled, so what will remain, x by 1 factorial plus here 3, this 3 and this 3 will get cancelled, in 3 factorial we will be having 3 into 2 into 1 is nothing but x square by 2 factorial plus same thing here, 4 will get cancelled, remaining is x cube by 3 factorial plus so on, right. This is dy by dx. Students, you observe this one, it is nothing but the given, what is given, y equals to 1, same thing, x by 1 factorial, x square by 2 factorial, x cube by 3 factorial and so on, right. This is nothing but y. Therefore, what we have proved? We have proved that dy by dx is nothing but y, right. We will go for the next problem which is fourth one. So, what we have to do? We have to find the derivative of this, right. Derivative of d by dx of the given thing. What is given? Square root of x plus 1 by square root of x square. This is equal to d by dx of a plus b whole square formula. You expand this by using the expansion. What will happen? A square, square root and square will get cancelled. So, what will remain? X plus 1 by root x whole square, 1 by x will remain plus 2 into root x into 1 by root x into 1 by root x, right. This is equal to, now you separate this root x will get cancelled, only 2 will remain here. First derivative of d by dx of x, then d by dx of 1 by x, then d by dx of 2. So, d by dx of x is 1 plus d by dx of 1 by x is nothing but, so better we will write like this, d by dx of x plus d by dx of, what will happen here, x power minus 1 plus d by dx of 2, d by dx of x is 1 and d by dx of x power minus 1 is, d by dx of x power minus 1 is minus 1 into x power minus 1 minus 1, right. Similarly, derivative of 2 is, derivative of 2 is a constant, derivative of constant is 0, 1 minus, what will happen here, x power minus 1 is nothing but x power minus 2. So, what we will get, 1 by x power 2, right. This is the derivative of square root of x plus 1 by square root of x into whole square, square root of x plus 1 by square root of x whole square. Derivative of this is 1 minus 1 by x square, right. So, all these derivatives we are evaluating by using the fundamental rules of derivative. What are the fundamental rules? First rule is derivative of a constant is 0. Second rule is if a function is multiplied with a constant, if we want to differentiate that, then constant should be kept as it is. We have to differentiate only the function. That was the second rule. Third rule is, if the functions are in addition, that is like this, 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, and so on. Then if we want to find the derivative of this whole thing, what we have to do? Individual terms we have to differentiate. That is first this one, then x square, then x cube, like that, right? So these rules are called as fundamental rules for differentiation. Have a look at this, students. Okay, students, we will see two more problems, and the difference in these two problems are, you can see that trigonometric terms are there. Like here sine is there, trigonometric function, and there sine and cos, trigonometric functions are there in these two problems. So how to solve this, right? So before going to the problem, what we have to do, we have to find the differentiation of this sine of x plus a, where a is a constant. So before going to this, we will see one formula that you have seen in intermediate, which is sine of a plus b is nothing but sine a cos b plus cos a sin b, right? And one more formula, cos a plus b is nothing but cos a cos b minus sin a sin b, right? Sin of a plus b is nothing but sin a cos b plus cos a sin b, and cos of a plus b is nothing but cos a cos b minus sin a sin b. So these two formulae that we are going to use in this problem, right? So what we have to do, we have to find the derivative of d by dx of sine of x plus a. This is equal to, how to find the derivative? Directly we cannot find, because it is not in the form of sin x or tan x or cos x like that. We can do, but we need to know what is the implicit function derivative. After that only we will be able to do. Right now we will use this expansion. So d by dx of sine of a plus b. In place of a we are having x, and in place of b I am having a. So sin a, that is sin x, cos b is cos a, plus cos a is nothing but cos x, and sin b is nothing but sin a, right? Then what will happen? Cos a is a constant, so cos of a is a constant, right? A is a constant, so cos of a is a constant. Cos of a as it is. Then what will remain? Sin x. Derivative of sin x is cos x, and plus sin a as it is. Sin a as it is. Then what will remain? Cos x. Derivative of cos x. Derivative of cos x is minus sin x. Minus sin x. Further, this can be written as cos a into cos x. This minus sin a into sin x. Right? Now you observe cos a cos b form. This is in the form of cos a cos b minus sin a sin b. Sin a sin b. In place of a we are having a, and in place of b we are having x. So this is nothing but cos of a plus b. Cos of a plus x. Right? Hope you have understood this. How we have evaluated the derivative of this sin of x plus a? We have used the expansion sin a plus b, which is nothing but sin a cos b plus cos a sin b. By using that, what we will get? In place of a we are having x, in place of b we are having a. So expand accordingly. Sin a is nothing but sin x, cos b is nothing but cos a is nothing but cos x, sin b is nothing but sin a, right? Because cos a is a constant, we have to keep as it is. Derivative of sin x is cos x. Sin a is as it is, derivative of cos x is minus sin x. Then what will happen? We will get this, and it is in this form. So by using this formula, we will get cos of a plus x, right? Now we will go for the next problem. There we are having sin of x plus a in the numerator and cos x in the denominator. What we have to do? We have to find the derivative of sin of x plus a upon cos x, right? D by dx of sin of x plus a upon cos x. This is equal to d by dx of, what is the expansion of this? Sin a plus b. Again the same thing, this formula we have to use. Sin x cos a plus cos x sin A. This is divided by cos x. Right? This is equal to d by dx of, here what will happen, cos A as it is, sin x by cos x. Sin x by cos x is nothing but tan x, right? Plus cos x and cos x will get cancelled, remaining is sin A, right? Next, how I am getting this? Cos A as it is, sin x by cos x is nothing but tan x, and cos x will get cancelled, sin A will be remaining, right? Here cos A is a constant as it is, cos A is a constant, I am keeping as it is. Then derivative of tan x, we know from the formula we know that derivative of tan x is secant square x plus derivative of sin A. Derivative of sin A is a constant, derivative of constant is 0. So what we will get? Cos A into secant square x, right? This is the derivative of given function sin x plus A by cos x. What is the derivative? Cos A into secant square x, right? Have a look at this, students. Okay, students, next topic we are having as product rule for differentiation. So previously we have seen if functions are given in the addition form, then how to find the derivative. Now we will see if functions are given in the product form, multiplicative form, then how to find the derivative of that. So consider, let f of x and g of x are differentiable functions. What I am having, f of x and g of x are differentiable functions. Then d by dx of f of x into g of x. I am considering the product of these two differentiable functions f of x and g of x. Then derivative of this, derivative of product is nothing but, so previously what we have done, if addition or subtraction are over there, then what we have done, we have found the derivative of f of x plus or minus, then derivative of g of x. We are not supposed to do like this here. Here what we have to do, at a time we have to differentiate only one function. That is, we have to keep f of x as it is, then derivative of g of x plus, right, plus d by dx of derivative of first function now into g of x. So if you consider this as a first function, this as a second function, then it is read as first function derivative of second function plus derivative of first function into second function as it is, right? How to read this? Derivative of f of x into g of x. How to define first function as it is, then derivative of second function, right? First function as it is, derivative of second function plus derivative of first function, second function as it is, right? Instead of this, we can even have d by dx of uv, where u and v notation is different, right? F of x, g of x, instead of f of x, g of x, I am having uv, where u is a function of x, v is a function of x. Then it is nothing but u into dv by dx plus du by dx into v, right? Or we can even write this as or uv whole dash. Dash represents the derivative with respect to x, right? This is nothing but u v dash plus v u dash, right? First we have to differentiate v, then we have to differentiate u, right? In general, instead of two functions, suppose we are having three functions. That is, in general, d by dx of, suppose I am having like this, f of x into g of x into h of x, right? Then what we have to do, at a time we have to differentiate only one function. That is, first I will consider df by dx, then remaining two functions. Remaining two functions are g of x and h of x as it is, plus first function as it is, that is f of x as it is, then differentiate the second function, plus First two functions as it is, f of x into g of x as it is. Then differentiate the third function, that is d by dx of h of x, right? So in general we are having the product rule like this, or else we can even write this as d by dx of u v w, which is nothing but u dash v w plus u v dash w plus u v w dash, right? So this is how the product rule is defined. What we have to do, at a time we have to differentiate one function, right? F of x as it is, derivative of g, then plus g of x as it is, derivative of f, right? We will see few problems related to this. We will consider the first problem. Find the derivative of, the question is given to be x sin x, right? Solution. We have to find the derivative of this. You observe that x is the first function, that is f of x, and sin x is the second function, that is g of x. So d by dx of, what is there? D by dx of x into sin x, which is equal to, we have to use this rule. So first function as it is, x as it is, then d by dx of sin x, right? Plus d by dx of x into sin x, right? This is equal to x into d by dx of sin x, derivative of sin x. Derivative of sin x is cos x, plus derivative of x is 1 into sin x as it is. So what we will get, x into cos x plus sin x, right? This is the derivative of x into sin x. What we have done, we have considered this as u and this as v. Then we have used the formula u v dash plus u dash into v. That formula we have used here. So what we have done, u is x, we kept u as it is, that is x as it is. Then derivative of v, v is sin x, v is sin x. So derivative of sin x, d by dx of sin x, plus again u dash, derivative of first function is x here. So d by dx of x, sin x as it is, sin x as it is, that is v as it is means sin x as it is. Then what will happen, x as it is, derivative of sin x is cos x, derivative of x is 1, then sin x as it is, right? So simplify, what we will get, x cos x plus sin x. So this is the derivative of x into sin x. So students, in the next class we will see few more problems related to this rule, that is the product rule for differentiation. Related to this we will see few more problems, and in next class we will also see what we have to do, how to find the derivative if functions are given in the quotient form, that is f of x by g of x. If the functions are given in this form, then how to find the derivative. That rule is called as quotient rule for differentiation, whereas this rule is called as product rule for differentiation. In the next class we will see quotient rule for differentiation and problems related to this. Okay students, see you in the next class.